So we left off here on the crust, and we're talking about the geosphere. To remind you, for the geosphere, what you're going to have to know is composition of the geosphere. Want to review that? What is a geosphere made up of? So it consists of three parts: core, mantle, and crust. What elements are found there? Iron, magnesium, silicone. Okay. Later. Main, oxygen. Good. You don't have to know about each, but you have to know general composition. You want to know that the majority of this class focus is on the upper mantle and crust. What makes up the upper mantle and crust? The lithosphere. Good. And the lithosphere consists of what inside of it? Plates. And that's what we're going to talk about today. We're going to talk about these tectonic plates that are found in the upper mantle and crust. So like you just said, the lithosphere makes up the upper mantle and crust. So why do these plates shift? Not shift. Shift. What rises? Heat. What do we call this heat? Magma. Okay? Yes, good. It's full of energy. Where is the magma originally found? The mantle. So think M for magma, M for mantle. The magma will flow. First it rises, and then it's going to spread across and flow like a river. What do we call this river of flowing magma? A asthenosphere. When magma, that super hot liquid rock, spreads across, what happens when heat spreads across, or liquid heat? Good. It solidifies because it's going to cool. Heat, when it spreads apart, cools. So it's going to solidify. This solid rock now is going to apply pressure to the plates, and it's going to cause them to shift. And there's going to be three different types of shifts we're going to talk about. So up here you see magma rising, spreading across, and then this is more like a volcano, but here you see it too. And that spread leads to solid rock that puts pressure on the plates, which can also pour through them and continue to rise. So we're going to talk about the different effects from the shifting of the plates. So there's three shifts, or what they call plate boundary guides on the way these plates shift. We'll start with the middle and this side, because everybody knows when the plates come together means what? Converge. Diverge means they move apart, okay? And then this one, that forms faults. Anybody know the word that's linked with faults and the shifting of the plates? T. Nope. So these are tectonic plates that are shifting. They either converge, diverge, or they shift this way or this way. Transform. Good. They're called transform faults or fault lines. So when you see this word transform, you're going to see or automatically think of faults. When you see the word convergent, you're going to think of subduction zones. Let me put something a little bit brighter so you can see what I'm pointing to. You also have to know the following. Convergent and divergent are linked to volcanic activity. Transform faults are not. Transform faults are the least damaging. This crack in the road is due to a transform fault, and it has to do with earthquake activity, but they consider it the least damaging. These, when you have convergent plate boundaries, anybody know what a trench is? What is it? What does it look like? It's like a dip. And you would think this would cause the dip, yes? But it actually comes together and pushes down and forms the dip. So you want to remind yourself of that trenches form through convergent plate boundaries where they come together and they put that pressure causing the dip. Because here we got another one. You think ridges looks like it would be this, but it's actually, well, I mean it is, but you would think it would be this and pushing together, but it's not. It's pushing apart, forms the ridges, okay? So you want to see these words and link them to each type of fault. I'm going to pause and say something for a minute. All right, so we know plates are shifting. What happens when they shift is the question. Who knows what happens when they shift? Earthquakes. What else? Volcanoes. What else? What happens when Earth shift during the birth of Earth? Good. Good. We got the formation of the continents. So one of the first things you want to know is that volcanic activity leads to formation of land. This is an image of what is believed that our continents once looked like. Pangea, and I have to remember to say this to my period I, Pangea is considered one big supercontinent. Why do scientists believe this was the case? Because when you look at the continents today, they're like a perfect puzzle that if you put them together, it looks like this is what they were all once connected. Do you think in the future I could have another one of these maps added over here to the right? Yeah. Sure, because the shifting of the plates continues, not to mention all the other things that are happening in the world, and these formations of land can shift as well. Volcanoes are a direct result of shifting of plates, so the magma can spread across or can pour out of land. The magma starts where? In the mantle, flows through the asthenosphere, and once it reaches land, so it pours out of the crust and hits land, it's called lava. So L for lava, L for land, M for magma, M for mantle. So underground, our liquid rock is considered magma. Once it pours out of the surface or pours through the crust and hits land, it's considered lava. So we'll do lava equals land. All right, earthquakes. Earthquakes also caused by the shifting of plates. We measure them. Anybody know what we use to measure them? Good job. Richter scale. And what the magnitude is from one to the other? How much greater is 1 on the Richter scale to 2 on the Richter scale? 10 times greater. 10 times greater. Earthquakes, very little, little to no warning. Same thing with what's this? Tsunamis. It's the same thing, guys. Tsunamis are basically underwater earthquakes. It's almost exactly the same thing. The difference is it's going to lead to this huge tidal wave. So you're going to have a shift in the plates, and the seafloor suddenly dips and then rises. I'm sorry, rises and then drops, or rises or drops. So dips or drops, dips or rises. Wow, I should redo that. So you're going to have this push and land, okay? And it's going to cause this upswell of a big, huge wave that pours over the land and wipes everything in its process. And there, right here, this animation, which you don't see in your notes, but you could see the wave pouring out. So you see that dip, and it causes that movement, and then that huge tidal wave forms and pours over land and basically destroys. So the only sphere that we're covering problems in or things that occur in the sphere is geosphere. We'll do hydrosphere and atmosphere later in the year, but the last part of the notes is going to be humans or people in throughout history. Okay, so we did the birth of Earth, and then we're going to do the population history. So that's the end of this unit.